Think about the last time you used a really great AI tool. Maybe you were hopping between Claude for heavy coding, ChatGPT for brainstorming, and Cursor for actually building. In the first week it feels like magic, but by week 3, you hit the wall. You find yourself typing the exact same context over and over and over again. Remember, we are using Python 3.11. Remember, my database is Postgres. No, don't use that deprecated library. Naturally, a gold rush has started. A wave of new startups is promising to fix this forever. They promise a universal permanent AI memory layer. A system that sits between you and every AI you use, remembering everything, connecting the dots, and making you a superhero. It sounds brilliant. The marketing websites look gorgeous. Investors are writing massive checks. But today, we need to take a look under the hood. Because if you strip away the sleek branding and look at the actual engineering reality, most of these AI memory platforms aren't a breakthrough at all. They are a ticking time bomb. And within 6 months, a lot of them are going to run straight into an architectural death trap. Let's talk about the brutal engineering truth behind AI memory wrappers, why they fail in production, and what it actually takes to build a moat in the age of commoditized AI. Alright, let's pick on the technical architecture of these platforms. If you read the press releases, you'd think these companies invented a whole new way for silicon to think. But if we look at the plumbing, it's a beautifully packaged collection of open-source tools that any mid-level engineer can stitch together in a weekend. Let's break down the stack. It usually boils down to 5 basic components. Component 1, an event ingestion pipeline. Every time you send a message, it grabs the raw chat, the tool, output, and some basic metadata. Component 2, a standard vector database, things like Qdrant or PG Vector. This is used for semantic search. Component 3, a small, cheap LLM model running a prompt that basically asks, "Hey, is there anything important in this chat turn? Is it a preference, a fact, or a task?" Component 4, a hybrid retrieval system that combines vector similarity with basic keyword filters and a recency boost. And Component 5, an MCP router layer. Model Context Protocol. This is the open standard created by Anthropic that normalizes requests across different apps. Look at that stack. There is absolutely zero proprietary foundation research there. It's a standard RAG pipeline, Retrieval-Augmented Generation, with an API router wrapped around it. Now let me be fair, being an integration company is not a crime. Building a smooth, friction-free user experience is incredibly valuable, but as an engineering reality, when your entire stack is built on commoditized, open-source infrastructure, your technical moat is practically zero. If a small team of developers can watch a couple of tutorials, plug in LangChain or Llama Index, spin up an MCP server, and replicate your entire core product over a long weekend, you don't have a tech advantage, you have a distribution race. But let's say you don't care about the tech being simple. If it works, right? Well, here is the dirty little secret of the AI memory space. Memory quality is the entire product, and human memory systems fail in incredibly predictable ways. When you launch an AI memory tool, day 1 is amazing, day 30 is pretty good, but by day 90, the architecture starts to leak. Why? Because of 3 fatal flaws in how these systems handle data lifecycle management. First, you have the extraction tax. Remember how I said a small LLM looks at your chat and decides what to remember? LLMs are notoriously inconsistent memory classifiers. Let's say you're working on a tight deadline, and you tell your coding assistant, "Look, I don't care about clean architecture right now, just give me a quick dirty script to patch this bug today." A naive extraction layer logs that and stores a permanent memory. User prefers quick dirty scripts over clean architecture. 3 weeks later, you're starting a massive, enterprise-grade project from scratch. You ask the AI for a boilerplate. The vector database pulls that old memory, injects it into the prompt, and the AI hands you a messy, unscalable piece of junk. You get noise, duplicates, and outright contradictions. Second, there is no automatic decay. Human brains are brilliant because we forget things that stop mattering. If you change your stack from React to Vue, a basic vector database doesn't know that your old React preferences are now stale. It just sees that they match the word front end. Without an incredibly sophisticated way to degrade, archive, or delete old memories, your AI's context window slowly turns into an ungoverned swamp of conflicting instructions. If the system tries to summarize too much, it loses all the critical nuance of your code base. If it summarizes too little, it floods your context window with useless noise that jacks up your API costs and degrades the model's performance. 90% of AI memory startups don't die because their servers crashed or because their UI was ugly. They die here. They die because managing the lifecycle of human context over a long period of time is an absolute nightmare. Even if a startup manages to write the perfect code to handle memory decay, they hit a massive, looming brick wall: platform risk. Let's look at the chessboard. Right now, these memory wrappers exist because the major AI tools don't talk to each other. Your ChatGPT memory doesn't sync with your Claude memory, which doesn't sync with your cursor index. The startup acts as the middleman bridge. But ask yourself, how long does that window actually stay open? MCP, Model Context Protocol, is an open standard. Anthropic literally handed it to the world for free. Why? Because they want an ecosystem where tools connect natively. What happens when OpenAI, Anthropic, and Google decide to implement native API-level persistent memory sync? What happens when Anthropic updates Claude to natively read your local system state, cross-session, across both their web app and their developer tools perfectly? In a single afternoon, an upstream API update can turn a $20 million middleware startup into a built-in toggle switch inside a settings menu. If the big platforms vertically integrate memory, the middleman layer evaporates. It goes from being a standalone product to a features list item that nobody wants to pay extra for, and that's not even mentioning the trust tax. Think about what you are asking a user, especially a software engineer or an enterprise company, to do. You are asking them to take their raw terminal logs, their proprietary codebases, their business ideas, and their private company prompts, and route them through a third-party startup server just to keep context synced. The adoption barrier here isn't technical, it's psychological and legal. For a lot of enterprise security teams, that is an immediate, hard, unconditional no. So, does this mean the entire category of AI memory is a waste of time? Not necessarily. But it means the current playbook of just building a sleek RAG wrapper around an MCP router is a losing strategy. If I were an investor looking at this space, or an engineer trying to build something that survives the next 5 years, I would look for a company doing at least one of 3 things. This is how you actually build a moat. 1. Moving beyond vector search to outcome-based ranking. Instead of just relying on mathematical similarity, vector search, the system needs to measure utility. If the AI pulls a specific memory, uses it, and the user accepts the code, that memory gets a reinforcement boost. If the user hits undo or corrects the AI, that memory is automatically flagged as stale or incorrect. It needs to be an adaptive, self-cleaning feedback loop. 2. Enterprise governance and permissions. The real money is in the enterprise, but you can't sell to them without bulletproof governance. A defensible memory layer needs granular permissioning. It needs to guarantee that a snippet of code or a preference captured while an engineer is working on Project A never accidentally leaks into the context window of Project B, avoiding massive compliance liabilities. 3. Aggressive ecosystem lock-in. If you can't out-research the big models, you have to out-integrate them. If a memory platform can build hundreds of deep, proprietary integrations that are so deeply woven into a developer's workflow that switching away would mean completely breaking their entire operational pipeline, then, and only then, do they stand a chance of becoming the Stripe for AI memory. At the end of the day, a lot of what we see in the AI space right now is incredibly clever middleware, sitting on top of rapidly standardizing infrastructure. Tools that solve today's annoying context fragmentation are fantastic for the short term. They fix a genuine pain point right now. But let's not mistake a well-timed product wrapper for a foundational technological breakthrough. The engineering complexity here is medium. The novelty is low. The reliance on distribution is terrifyingly high. If you're building in this space or looking to integrate these tools into your workflow, keep your eyes wide open. Don't fall for the marketing glow. Look at the plumbing, watch out for the data swamp, and always build with the assumption that the underlying models are getting smarter, faster, and more integrated every single day. What do you think? Are you using a dedicated memory tool right now? Or are you just waiting for the big model providers to bake this into their platforms natively? Let me know in the comments below. Hit that subscribe button if you want more honest, unsugar-coated breakdowns of the actual engineering reality behind the AI hype cycle. My name is your name. Thanks for watching, and I'll see you in the next one.